everyone. In the previous video, we just saw about series connection, and I had mentioned that we'll be talking about parallel connection. So as you can see here, there are three pictures, right? The first one which I'm going to talk about is this, right? So can you see here, there are individual one, two, three, four, five, six bulbs. Each bulb is having a separate wire connected to it. They are not connected with one wire in a continuation, right? So there are separate wires which are connected together and that has been put into the switch box. So such a connection where individually they are connected is called as parallel connection. Our switchboard normally in our houses have parallel connection. Why? Because we can connect a charger of our mobile phone, we can connect a battery of a laptop connecting, or we can connect a fan. Each instrument or each electrical appliances require different amount of current. So we connect it in this way. Now, if you want to do it in a very small way in a lab, then what you do is you take two bulbs. Can you see they are connected with different wires? Okay, we call it as the parallel connection. There is a different wire connecting this bulb. There are two different wires which are coming out of this bulb, which is the positive and the negative, and connected to the battery. Same way, there are two wires connected from here. So this is a parallel connection. Individual bulbs will glow according to their requirement. Okay, so a quick look into the virtual lab and we'll see how a parallel connection should be connected. And now you observe whether the voltage is changing or the current is changing. Okay, so let's have a look. Okay, this time I'm going to take batteries. Instead of batteries, I'll take bulb. So it's very easy to understand that. Okay, or maybe I take a bulb and a resistor. Let's see. Let's take two batteries. Okay, I'm going to change the voltage. Let's take them as to be 40. No, let's take 12 volt battery. Both of them to be 12 volt battery. Okay, so I've changed them into 12 volts. Oh, let's shift a little bit. Yeah, 12 volt. Okay, now I'm taking three bulbs. First bulb. Let's do a simple one with two bulbs. Okay, so that's more easier to understand. Each bulb will have its own positive and negative terminal connected to separate wires. Okay, there's nothing common connecting them. Nothing one after the other. That is the first rule for parallel connection. Let's put the ammeter like here. Okay, let's connect that. And let's extend it. Now something interesting that you need to note is this. If I'm going to put a wire, please pay attention how we should connect it. Oh, I forgot to put the key, right? Okay, let's put the key somewhere here next to the battery. Okay, right? Now if I'm going to connect a the key directly to this one, then what is going to happen? Just watch, huh? Then just watch what will happen. There is no connection here. It looks like the wires of this battery bulb is connected, right? But still watch when I close the key. Only the bottom bulb is glowing. Why? Because I forgot to connect the middle one, right? So what we have to do is we'll put the wiring of this one and I have to cut this off from here. Sorry, I need to make it small. Yeah, connect it like that. Correct? Let me cut that first. Next, I'll take a wire which will go from here to here. So are they connected now properly? Okay. Let's change the ohms for the battery. One is 10 ohms. Let's change it into a 12. Now let's change it into a 12 ohms. And the other I'm changing it to a 15 ohms. Then gradually we'll reduce it and see what happens. Okay. My ammeter is already connected. Let's do a 15 ohms. Oh, yeah. Okay. Let's take the voltmeter because that's very important to note down what is the situation. Okay. So let's put on the key. Let's see what happens. Is the bulb glowing or not? Let's see. They are glowing. And it's a very fast moving. The current is 3.60, right? Now, why did I connect here? Anywhere if I'm going to connect, it will show me the same value. I'll show you in a few minutes. Okay. Now, the voltage. 24. 24. So is the voltage is not changing and the current is also not changing. Let's check which is changing. Okay, let's open the key. Oh, sorry. Let's open the key and let's place the ammeter next to this first bulb. Then we'll place it to the second bulb. So I'm going to connect the ammeter one here next to my first bulb, and I'm connecting one more ammeter next to the second bulb. So that way, sorry, I'll be able to show it very clearly what is happening between the two. Okay. One more ammeter connected, right? Okay. Let's now connect the battery and see bulb key and see what happens. Now see the current, 2 ampere, and here 1.60. The voltage is still the same, 24 volt and 24 volt. If you remember, what was my battery? 12 volt and 12 volt, right? So my 24 volt voltage is same. It's not changing wherever I'll keep it. But what is changing? My current. If you remember, this bulb was 12 ohms. The current is 2 ampere. And this bulb, the current is, sorry, the resistor is 15 ohms. The current is 1.60. So the resistance is changing. It is 12 and this is 15. The current is 2 ampere and here it is 1.60. The voltage is not changing. The current is distributed. So this bulb needs less current, so less it's moving, and this is needing more current, so more it is. Okay. So the resistor is less, so more current. The resistor is more, so less current. I used the wrong way, sorry. The resistor is more in the second case, right? So more current. No, less current. Okay. And here less resistor, more current. Inversely proportional, right? So let's look into the circuit diagram and how to go about with the resultant resistance calculation. Okay. Okay, there we are. I had showed two bulbs. Now I have taken three resistors, each of different voltage. Sorry, different resistance. Therefore, the current is different. So looking at the current, can you directly say which volt resistor is the maximum out of the three? This is the lowest current, so the voltage will be, sorry, the resistance will be maximum. So let's say R2 is the maximum. The lowest will be this one because the current is highest. 3.60 is the highest. So the resistor is lowest. And here it will be medium, which is R3. So current is 1.80. That means the resistance is highest, R2. The current is highest, that is 3.60. Therefore, the resistance is lowest. Same way for the battery, one resistance and two bulbs. Sorry. So here the bulb is having 1.47 ampere current. The second bulb is having 1.63 ampere current. So which one is having more resistance? This one, which is R1, right? Because less current. R2 is comparatively less to R1. And what about the resistance wire which I have put? It has the maximum current. So can we say R3 is the lowest? Okay, and current is maximum in this case, right? So now if you want to draw in a circuit, this is how we show the parallel connection. Okay, the three resistors are drawn like this. They all are connected at one point and the voltmeter is put across that one point. And then there are three diversions showing three different currents. So this is I1, this is I2, this is I3. Okay, the general current coming out is I. The voltage is V. So the current is distributed and the voltage remains same. Okay, sorry, let me go up. So what happens? Voltage remains same and the current changes through each resistance, right? So again, the same thing, voltage of the battery is V, current is I, voltage of the first resistor is R1 resistor is V, current is R1, resistor is R1. Sorry, I1. For the voltage of resistance R2 will be again V because it's same, current is I2, resistance is R2. Voltage across the resistor 3 R3 is going to be V, current is I3 and resistance is R3. Now in this case, it is observed that the total current is equal to the sum of the separate currents passing through each combination. So total current in the circuit is equals to I1 plus I2 plus I3 because current is the one which is breaking off and distributed, whereas voltage is remaining the same. Okay, so again we are going to apply Ohm's law for each case. Let's say the battery. So for battery, V equals to I1 R1. So can I say V upon R1? Sorry, not R1. I'm so sorry, it's I and R. Okay, so IR. So can I say current is equals to V upon R, right? For resistance, for resistor 1, it will be V equals to I1 R1. So can we say V upon R1 equals to I1, right? Next, resistance, sorry, resistor 2, V equals to I2 R2. So V upon R2 is equals to I2, right? Then resistance or resistor 3, V equals to I3 R3. So V upon not I3, R3. R3 is equals to I3. So we just now said that total current flowing in the circuit is equal to addition of these individual current flowing through individual resistors. So we'll say I equals to I1 plus I2 plus I3. Okay. So if you have seen, I is what? V by R. I1 is V by R1, V by R2 and V by R3, sorry. So we'll say V upon R equals to V upon R1 plus V upon R2 plus V upon R3. So can we take the V as common in the right side? Yes. So V comes out 1 upon R1, 1 upon R2, 1 upon R3 is V upon R. So the V and the V gets cancelled off. So the reciprocal of the total resistance is equals to the sum of the reciprocal of individual resistance. Reciprocal, why I am saying the word? Because 1 upon. The total resistance of the circuit is equal to what? Reciprocal. 1 upon R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Clear? Now, what is the key rule between series and parallel connection? In series connection, it is the current which is changing now. In series and in parallel, a quick review. Constant is which one? In series, it's current. And here, the constant in parallel connection is which one? Voltage. Okay, and changing factor in series connection is voltage, and changing factor in parallel connection is current. Just the opposite. So in series connection, voltage is the one which is distributed among the resistors, and in parallel connection, it is the current which is distributed among the resistors. Okay, a quick advantage and disadvantage of series connection. A series connection is not preferred because there is a throughout the circuit same amount of current flows. So if I am connecting electric bulb and electric heater, both of them require different amount of current. So if I am going to connect them together, either one of them will burn off or the other is not at all using it because it is not getting adequate amount of current that it requires. Okay, so and the second rule is if one of them fails, like in an electrical series bulb, when you connect in a wedding or a Diwali function or a Christmas, and you have seen this, the electricians, they connect these big electrical decorations with the serial bulbs, but then halfway you see that it's not burning or it's not glowing. Why? Because one of the bulb would have broken. Once the circuit breaks off, the current further on will not flow. So if one of the components fails, then the circuit is broken. So none of the components further on will work. That is the biggest problem. The electrician takes time, really hours and hours to figure out which bulb burnt out. Okay. Whereas the best advantage of parallel connection is, in parallel connection, each device will get their own required current because the current is divided. Okay, and each electrical gadget will have their own resistance. So according to their resistance, that much amount of current will flow and the gadget will be used its utmost level. So you can connect a fridge, AC, a battery charger of my mobile phone, a TV, but all of them will be connected in parallel because all of them require different amount of current. Okay, so that's the biggest advantage of parallel connection. So we just covered which one? Series connection and parallel connection. I hope